see later. Thus far, what we've talked about is this right here. Now, in the mathematics, you use the term if and only if, okay? The necessary and sufficient conditions. And the necessary condition for having a gas feature show up is that on the PP data, that is to say P wave down, P wave back, standard P wave data, that you have an amplitude anomaly. It could be a plus, a minus, a dim spot, a flat spot, but something is anomalous about the amplitude. That's the necessary condition. The sufficient condition is that the shear wave data shows nothing. Because if it's a container, it shows up here and here. The Earth is a wavelength filter. So if I have a container, I'm currently working on for a client some work in the Hackberry. The Hackberry is a Frio Formation submarine channel over in Jefferson County, Texas. Oligocene age deposition and Oligocene age faulting. So it's a submarine channel filled with debris coming down that submarine channel. And you have nothing but shale in the Hackberry material that filled in that submarine canyon feature, except for the occasional sand lens. And so these things look like little fish floating in an otherwise homogeneous shale with no real reflection events. And if that's all it is, if it's just a little fish floating out there, it'll have a PP data anomaly. You don't know unless you have shear wave data whether or not that's a container or whether or not it's a container with fluid. If it's a container with fluid, the container might show up at the fluid one on the SS data, which is problematic. You say, well, what good is shear wave data going to do? It's nothing perfect about it. But if you're trying to get if you only have a container feature, a so-called issue of tuning, then it's going to show up on both features. Because the Earth is a wavelength filter, and that shear wave data will scale back in velocity and in dominant frequencies so as to be the same wavelength. So it'll both have tuning at the same place in the same way, pretty much for a feature that is full of brine and it's simply a tuning effect. It's complicated if you have a feature that shows up like the Hackberry does that may or may not have gas in it. Then it gets complicated because you might be seeing just the container on the shear wave data if you have it. So nothing is simple. Here's the other feature. The P wave anomaly will show an increase in energy with angle of incidence. A lot of times they'll talk about not energy but amplitude, and they'll change angle of incidence into offset. But in fact, it's really an energy change irrespective of the phase of the signal being demonstrated. And of course it is angle of incidence. It hasn't got anything to do with offset, except that's how we take data. So we interchange that. Lastly, the mode converted shear wave data will actually extinguish. So let's go back to a simpler anomaly. If you have an anomaly that's just a tuning effect, it will show up here and here. If you have an anomaly that is just a hydrocarbon effect, no tuning, it'll show up here but not here, and the mode converted shear wave will actually have an extinguishing effect. It'll actually have no data at all. And so that's an underscoring of what you'll see later with real data when we talk about PP data, SS data, and the mode converted shear wave, sometimes known as C wave data, because it's converted wave data. So PSC, converted, or PS, your choice. So that's sort of an overriding bright spot recipe. Current thinking on P waves, and let's just pick on class 2 and 3 because that's what you're going to see today in real data is class 2 and 3. Let's ignore class 1 and class 4. But if you look at Castagna and others, talking about the work of Rutherford and others in terms of classifying these events, what you'll see is, let's talk about a class 3 bright spot. In an AVO sense, what you're going to see is a bright spot showing a negative reflection coefficient and pretty bright. And with offset or angle of incidence, that brightness increases. Okay, that's a type 3 amplitude anomaly, Gulf of Mexico. Negative reflection coefficient, significantly bright, even getting more bright with offset or angle of incidence. That's class 3. Class 2 is somewhere around 0, maybe high, maybe low, but in any event, it doesn't distinguish itself as a reflection event. But with offset, becomes negative. So class 2, one side or the other of 0, not distinguished, but with offset or angle of incidence, much bigger. Now here's a picture, a more current picture of this same phenomenon. Here's the class 2 angle gather, and then here's the class 3 angle gather. You'll notice on the class 3 angle gather that even the normal incidence trace is pretty big. With offset, or angle of incidence, interchangeable comment, it gets really big. So the zero offset trace looks like this. The stack trace looks like that. That's class 3. Let me back up one slide here to make one other comment. In fact, I'll write it on here. In the Gulf of Mexico, this is also geologic time. And that's pretty much true of any basin. But these features here are normally Pleistocene, and this guy here is Miocene. So geologic time is older is that way. Okay. Yeah.
We said to skip class 1 and 4, but I realized that class 4 behaves different than others.
I have never dealt with a 1 and a 4 from the petrophysics, so I've never seen the log work up to know what's happening. I know that 1 is sort of a land thing, and they're harder to come by. In fact, the little history here, the whole world of amplitudes might mean something on seismic data originated here at Rice University. The man's name is Jean-Claude de Bremiker. He's a professor emeritus of geophysics, and his student was Percy Pan. He goes by Percy Pan now, but if you look up Pan, circa 1970, 71, his dissertation talked about amplitude anomalies for exploration seismic data. And he had 3 examples. One was on land, and one was oil. So it's kind of interesting. He had an oil example, a gas example, and a land example, and made the case for all 3 of them, and really started things rolling for, wow, I wonder if there's any truth to that. I wonder if Percy Pan is right. But Jean-Claude de Bremiker was when I first came here in 01 as an adjunct, his office is right across the hall from me, and he's only been recently kind of not on campus anymore. Jean-Claude de Bremiker. So geologic time going this way. These are the Miocene events you'll see in a minute with real data. These are Pleistocene events. That's a land phenomenon, and frankly, I don't know what the class 4, I don't know the petrophysics of it, so I just would screw it up. But, everything I say here, especially when I give a reference, and especially when I give a better reference, like today's stuff, that I actually show you. If you go pick up The Leading Edge, September of 12, this is discussed quite a bit by this author. So that's why I tried to add for my newer slides where to go find it and read it in detail. But again, what's happening here is, and I'll just stand up and point for a change. Okay, class 3 for the angle gather starts big and gets bigger. 35 degrees is a pretty realistic end for angle gathers, say Gulf of Mexico. The 0 offset trace or the stack trace both shows a nice brightness. Look at class 2. It could start off positive and with offset or angle of incidence go negative. That's on the other side of 0. Or start off very, very slightly negative, we would never see it, and become negative. So the 0 offset trace can have a positive feature. But the stack trace is going to kind of wash out. If you move it out and stack it together, it kind of goes away. You're gonna have plus and minus kind of killing each other off. Whereas the stack trace for this side of the class 2 might show up as an anomaly. You'll see examples of all this in a minute with real data. And keywords on this would be John Castagna, professor at University of Houston, Jean-Claude de Bremaker, professor emeritus at Rice University, Posey, Pan, Rutherford, I don't know. But all these people are walking around and could be checked out on any web search. Now let's switch to 3D. That was the other